Hey, this is Mr. A, and again, preparing you for the quiz tomorrow. I ask you to take a look at questions 6 through 8 on page 4 of your study guide. And this was a problem where we had a crate being pulled along greased tracks, and so it's a problem much like we've been working in class, and in fact we've been working on problems like this for a while when you consider that it is a one-dimensional problem. So I hope you had a chance to take a stab at this, and let me kind of walk you through it. Here is the 1,000-kilogram crate on these greased tracks, and there is a winch that's pulling the crate with a force of 2,000 newtons, and we're told that the coefficient of kinetic friction is 0.2. Now the first thing they wanted us to do is to draw a free body diagram. Of course, you're going to draw a free body diagram, and so you're going to draw the forces involved. Of course, we always have the force of gravity, which is pulling it down, force of gravity, Fg equals mg, Fg equals mg, Fg equals mg. We are told the mass of the crate, but I'm not going to plug that in there right now, but I just want to make sure you are keeping up with your mantra. We see that we have a force pulling off in this direction. We're going to call that force applied. And there is friction involved here, so we've got to consider that. Now, right now, I'm going to draw these vectors close to the same size. I'm not really sure if I'm going to have a net force or not. I think that's going to depend on how some of these numbers work out. Well, the last problem says calculate the acceleration, so I bet there's going to be a net force. But the question doesn't say that the crate is bouncing up and down or is accelerating in the y direction. So we're going to have a normal force. It's normal for there to be a normal force. So it's going to be equal size in comparison to the force of gravity pulling it down. Okay. So what the equations that we are going to use to solve this problem are very much like the elevator type problems that we've been working with before. It's just that we have this friction force involved now. So if we want to know what F net is, and that is the question number 7, it is simply whatever the difference is between this force and this force. These forces some of the forces in the y direction are 0, but we don't think that the sum of the forces in the x direction is 0. So we can go ahead and write that F net now is just going to be the sum of the forces, force applied plus force of friction in the negative direction. Force of friction in the negative direction. Okay. Now we also know that F net is going to equal the mass times the acceleration. If there is a net force, then it's going to accelerate the mass proportionally. Okay. So what are we trying to find out? What is the net force? Well, we don't know the acceleration yet, so we're not going to be able to use this equation. Maybe we can use this equation. We know that a force applied is 2,000, so let me find some space to write down here. Force applied is equal to 2,000 newtons, and the friction force, we're going to have to use our friction equation, is equal to the coefficient of friction times the normal force. Well, the normal force is it's got to be the same as the force of gravity, and that means it's also going to be mg. So now I can write that F net is equal to the applied force, 2,000 newtons, minus the friction force, which is mu k, which is 0.2 times the mass of 1,000 times the force of gravity, which is 9.8. Wow, okay, I squeezed it all in here. Now we'll use our calculator. And it turns out that 0.2 times 1,000 times 9.8 the net force is going to be 40 newtons. Okay? So 40 newtons is the net force. We know the mass, and now we can calculate the acceleration. Acceleration is going to be equal to the net force divided by the mass, which is going to be equal to 40 newtons divided by 1,000 kilograms. Okay? And 0.04 meters per second squared. All right? We're really tearing it up there.